Welcome back to the LOOC. This is Peter again, and in this segment we are going to continue looking at C# programming. The first task that we'll complete is a modification of our original welcome or hello world program while still retaining the same output. It will be a single line output of a string, but we are going to write it in two statements or two commands instead of one. We are going to use the write method as well as the already known writeLine method of the console class. And the difference is that the writeLine method places a new line character at the end of its output and thereby positions the cursor at the beginning of the next line in the console window, unlike the write method that just stops wherever its output ends in the middle of a line and waits for the next character to be typed in by the user. This is what our program will look like. Two commands. The first one prints out the first half of the output, welcome to, and then pauses at the end of the space following to, and the second line completes it by putting the word C# programming and then a new line. So in this case we display a single line by two statements that combine to a single output line. So let's try to do this, returning to our original welcome program that is on the screen. So to modify this, I need to turn the writeLine statement into a write statement and remove the end of its output by Ctrl X. And then add a new line and type in my new command, which will be also a console command and a writeLine method, and we place in the string that we took out, close the string and the statement. It is also useful to place a space at the end of after every opening round parenthesis and before every closing round parenthesis. This kind of spacing makes our code easier to read, makes it more readable. So I'm ready to save this version of the program, and I'm ready to build and run for debug. So it would be build solution F6 and then Ctrl F5, but I can actually shorten that by simply hitting Ctrl F5, which causes the program to be rebuilt and run. So here is the result of the modified program, still a single line of output, but created by two consecutive statements. And hitting any character will close the program. A further modification is when we print out multiple lines, and we could print out multiple lines either by a series of writeLine statements, but another option is to display multiple lines using a single statement and new line characters placed into the output string. Our code will look like this. This time a single writeLine method of the console object, but new line characters are placed into our output line. This will break our output into several lines. The new line characters are so-called escape sequences. A backslash is an escape character, and an escape sequence follows, which is the first character of the rest of the string and indicates what kind of effect we want to achieve. For example, the escape sequence \n constitutes a new line character. There are others, \T for a horizontal tab, \R for a carriage return. Know the difference between new line and carriage return. And if we just want to print out an actual backslash, we have to put in a double backslash, because backslash alone will combine with the next character as an escape sequence. And similarly, if we want to print out an actual double quote, then we have to place a backslash double quote, because the double quote is already used to enclose a string, as shown in the example. So going back to our code, we want to break up our code as shown. So let's do it. In this case, we are going to print out our entire output string as it originally stood, like that. So I don't need the second statement. And it is a write line method with spaces after the opening parenthesis and before the closing parenthesis. And now, if I want to break it out to multiple lines, then basically I can just put in a new line in place of every space. So \n after welcome, \n after 2, and maybe \n after C# as well, like that. It's a somewhat odd looking string. Trying to save the program, and Ctrl F5 will compile and run it. And here is the result of our output broken up into 4 lines. So every word is on a separate line using new line characters. There's another way to achieve similar outputs using the write and write line methods, and that is to use a format string. This is the example of the code, a write line method, and this time instead of a single argument, it actually has 3 arguments separated by 2 commas. And the first one is an odd looking string which clearly contains a new line character in the middle, and then 2 parameters 0 and 1 in curly braces, and then the 2 half strings, so to speak. And the result will be the 2 line that we see in the slide, welcome to as 1 line and C# programming as the second line. So multiple arguments are used, separated by commas, and it's a good idea to place a space after each comma in a list of arguments so that the program is more readable. We cannot break a statement or split a statement in the middle of an identifier or a string, because that will be a syntax error. So our new way of printing out our output will be the use of a format string, and in this case there is a format item and some fixed text within the format string. So in our example, there will be 2 format items which are placeholders for values. So 0 in curly braces is a placeholder for the first half string, which will be our first additional argument, and 1 in curly braces is a placeholder for our second argument, our second half string, and we could have more. So we could have broken our string into 3 or 4 parts, and there would be 0, 1, 2, 3, 4, and so on. And the format items, in addition to these placeholders, can have optional formatting information, such as the new line in the middle. So let's try to write our program this way. So, go back here to the going back to the actual code like that. So that's what we are going to actually carry out. So here is our original string. In this case, we are going to remove the new lines and restore the spaces. So there is one argument, welcome to, comma and space, and our second string, which would be C# programming, with a space after C#. So these are the two additional arguments, two half strings, and in front of them will be a format string. In our case, it will consist a placeholder in curly braces starting with 0, followed by a new line, and then a placeholder in curly braces identified as 1 for the second argument, and a comma. So here is the comma separated list of the arguments of the write line method, the format string with the two placeholders separated by a new line, and the two content strings corresponding to the placeholders, welcome to and C# programming. So we can again save the program if you like, separately rebuild it to check if there are any errors, and if there aren't, then Ctrl F5 will run the program, and here is the output showing the result of using a format string followed by two content strings. Again, note in the formatting of the code itself that I place spaces after the commas to improve readability of the code. That completes our various ways of using the write and write-ln methods for text output. However, of course, programs can do far more than just writing text. In particular, they can also carry out arithmetic, logical, and other operations on data, process data, and create useful results and output those results, going way beyond just textual data or strings. When we do so, we sometimes need to use multiple items of data, such as numbers or other kind of data, strings, as well as there are many other types, and the applications or programs we write have to remember these so that they can process them. And therefore, we place these values into little items of storage within the memory of the computer called variables. So basically a variable is in effect a named storage area in the computer's memory. So it is a location in the computer's memory where a value can be stored for later use, and it has a name or identifier. A variable declaration statement, simply a declaration, will specify the name and type of the variables. The name or identifier allows the application to recall it, and the type specifies what kind of information is stored. So here is an example of a very simple application called addition that simply adds two numbers. It's a short program, and in this case, number 1 and number 2 and sum are three variables, three declarations, and we ask the user to type in two values, and then when that is complete, we display the result. So our output will look something like that. If the first integer the user entered is 45 and the second is 72, then we will display that the sum is 117. In this program, int, the type declaration int, means that we are storing integer values, that is whole numbers. We can also use float, double or decimal types, which is for real numbers, that are real numbers with decimal points. Both can be positive or negative or zero. A char type represents a single character, and these and many others are so-called simple types or native types, and their names are keywords in lowercase letters. We can declare a variable on multiple lines, and we can also place multiple declaration on a single line with comma-separated lists of variable names. And this is especially useful when they are of the same type. When we name variables, give identifiers, it's a good idea to use so-called talking names or self-documenting names that indicate the purpose of the variable. So instead of x, it might be better to use a variable such as sum, which shows that it is the sum of some other values. Even though we can place multiple statements on a line, it's a useful practice to declare variables on separate lines, because we can add comments to these declarations. Generally, identifiers start with a lowercase letter, and then if it's multiple words, each new word starts with a capital letter, and this convention is known as lowercase camel casing. We'll see an example of this in a second. If the first letter is uppercase, then it's called uppercase camel casing or Pascal casing. In this program, we are going to follow the most common lower camel cases, where the first letter of a variable name is a lowercase letter, and we alternate the cases to indicate the words that make up the variable's name. The readLine method is a new method of the console object that waits for the user to type a string of characters and hit the enter key to indicate that the input is complete. readLine will return the text the user entered. It's important to remember that these are always strings, even if they are made up of decimal digit 1, 2, 3, 4, and so on. It's still a string, so the string double quote 1, 2 followed by a second double quote is still a string consisting of two characters 1 and 2. It's not identical with the number 12. If we want to extract, so to speak, the number from such a string, we have to use the convert object or convert class that has the appropriate methods. For example, if we want to convert it to integer, in this case actually a 32-bit integer, that the toInt32 method will convert these characters into an int type, and then we get the actual numbers. Going further, the assignment operator, which is a single equals sign, can be used so that a value is placed into a variable. It's a binary operator because it uses two pieces of information or operands, one on the left hand side, one on the right hand side, so they are often called LHS and RHS, left hand side and right hand side, and assigns a value to a variable. And note that the right hand side is completely evaluated before the assignment is performed, because on the right hand side there could be a complicated expression. Again, it's important to remember that the assignment operator is a single equals sign, because later we'll see a double equals or equals equals sign, which is a different operator altogether than the assignment operator. And it's also a good idea to separate the equals sign with spaces on both sides. On the right hand side, typically there is an expression that specifies some kind of calculation or some way of combining multiple pieces of data. For example, number 1 plus number 2 creates the sum of the two numbers, and the read line is the value that the user typed in, and read line can also be used to perform calculations within the input part. Variable names are identifiers for us when we write the programs, but they really correspond to particular memory locations in the computer's main memory, or RAM. And they have four characteristics: a name or identifier, a type that indicates what kind of information is stored there, a size which can vary depending on the type, and a value. So for example, in our case, when we assign the value 45 to number 1, then we use the assignment operator, and number 1 had the name number 1, the type int, the size 32-bit integer, and the value 45. Once done, conceptually the number 45 is stored in a memory location called number 1. And then we do the same thing for number 2. Then that value is stored in the next memory location with its different name, number 2. And then when we add the two numbers and place the result in a third variable, sum, then that is stored conceptually in the third consecutive memory location with its own name, sum, and value 117th. Note that when we place a value in a memory location, it replaces to whatever value was in that location. It often happens that the same variable gets assigned multiple times, so during its lifetime, so to speak, it obtains multiple values. When that happens, the previous value is not necessarily deleted or erased or set to 0 or anything like that. It just sits there, and when we do a new assignment, the new value will simply replace or override the previous value. When we read it only, then it's not a destructive operation, so the value stays the same. And the operators that we used in this program segment are the arithmetic operators, and they are a list of them. They look very similar to high school algebra, so plus, minus, an asterisk for multiplication, a slash for division, and the percentage sign for the remainder operators. So plus indicates addition, minus indicates subtraction, asterisk indicates multiplication, slash indicates division, and the percentage sign indicates remainder. So let's go back to our program when we are adding up numbers and type in that code. So again, the code was here, starting there. It's called addition.cs. So if I go back to my program, then I could create a new program, but in this case I will just modify what I have. All I need to do is simply take out that line, and if I want to, I can change the name of this class to of this file to something like addition, which will rename the class name, and I can even rename the project name to addition, which will change the project name, and if I want to, I can change the namespace as well to addition, like that, and save it. So having done that, we can rebuild as it is, as an empty solution. Generally, I wouldn't recommend to do this because it's better to write new programs instead of modifying old ones, and I am renaming even the solution name and save it and rebuild it just to check that there is no error. And it looks like I have a brand new program, but in reality I don't. I just renamed everything, but it looks like a new program. So there we are. So let's type in our code. So tab. So we create a new variable called number1, and after a couple of tabs I can add the comment. So declare first number to add. Let's continue with the next one, int number2, and a similar comment of declare second number to add. The cursor out of the way, int sum, and this will be declare sum of number 1 and number 2. That will be our next variable. We can leave a space if we so choose to show the code a little bit more structured, and we are going to send a message to the user to enter a number. So it will be a console write method, not write line, saying something like enter the first integer, colon space, and that will be our prompt. So we will call it as prompt user, and then once we prompted the user, we are going to read the first number, read first number from user, and this will be an assignment, and therefore on the left hand side we are going to write number 1, which actually IntelliSense gives us, equals, spaces on the two sides of equals, and we are going to read the next integer that the user types, and that will be a console dot this time read, and in fact a read line operator, because we want to read everything the user typed up to a point. I could technically leave it like that, but that would be a problem, and the underlining already indicates what that cannot convert type string to int. The bottom line of the message. So it already indicates that as it stands it wouldn't be correct code. So we have to convert this, and to that effect we have to use the convert class toInt 32-bit integer conversion, and that's where the console read line will be. And after a space and completing, now there is no underlining. So indeed we are assigning number 1 an integer as we declared its type. And then we can do the same thing for the second integer, and sometimes when I do very similar things twice, instead of retyping the whole thing, I can just highlight and Ctrl+C for copy, then move my cursor to where I want my code go and do Ctrl+V, so the whole thing gets copied, and then I just need to modify it. So instead of first, it just should say second, and maybe in the command line 2, second, and this will be number 2 instead of number 1, and that takes care of the input. So we are entering 2 lines. Because these are read lines, the user has to hit an enter when they are done with one number or the other. And then now we can do the calculation. So sum will be the variable, and it's an assignment, so a single equals sign, and number 1 plus arithmetic operator plus number 2, and I can add here something to the effect that add numbers, maybe even adjusting there, and finally displaying the result, which is a console object, console class write line method, and we are going to use the string formatting we are used to. So sum is, and in curly braces a placeholder for the actual content, which will be the word sum, and that completes the display. And we can comment it here saying that display sum, sum is, actually I left out the quote there, and I noted it instantly because the error indications. And sometimes it's useful for further readability to add comments like this after closing curly braces, that this is the end of the main function and main, and maybe that the second one is and class addition, like that. And with that we are done there. And then of course if we really want that, is add of namespace addition is the final curly brace. So let's save this, and let's build a solution to find if there are any errors. And there is one on line 6. We can just double click and it will go there, and it indicates my problem that the namespace actually is supposed to open an opening curly brace. So let's save again and let's try to compile it one more time, and this time it's successful. So note that I lost that opening curly brace of the namespace when I changed the name of the namespace. So now with Ctrl F5 we can run the program, and it asks for enter the first number, 45. I have to hit enter key to indicate that I'm done typing. The second number, maybe 72, have to hit the enter key, and then it says that sum is 117, and that's the output of this program, reducing the command prompt a little bit. Oops, not that much though, just a little bit, and then moving it down here so that we can see side by side what the code is and what the result of it looks like. So again, what we did is entering two integers and adding them up and displaying the result. At this point I can hit any key, and that will stop the program, and we can stop this segment here and we continue in the next one.